FK-driven IK means that the FK solution drives the shape of the IK solution. The FK solution can be animated in any way the user desires. This means that the bending of a knee can be bent in any axis throughout the animation. The artist has complete control over the bending of this knee. If we select the foot of this character and move it around, we can see that the whole leg is being solved for IK. One of the aspects of this IK system that we'd like to modify is the way that the IK system interacts with the IK target. When we rotate this IK target, the knee does not follow the IK target at all. If we select this leg and put the leg into FK, we can see that the FK solution ignores the IK target, and this is why the IK solution ignores the IK target. We can fix this by simply selecting the thigh and looking at the available controllers. On the current layer, we're going to look at the rotation controller and reassign an orientation constraint. Orientation constraints allow us to force bones to mirror the rotations of other bones, and in this example, we're going to make the thigh bone inherit rotations directly off the IK target. So to do this, we turn on Keep Initial Offset and add the IK target as an orientation constraint. Here we can now see that when we rotate the IK target, it's affecting the rotation of the thigh. If we select the thigh, our bone is still in FK, so when we move the IK target, it's actually ignoring the IK target, its IK system. If we select the thigh and go back to our limb IK rollout, we'll put this limb back into IK, and now we can see that when we move the IK target, our limb is being solved for IK, and also the orientation constraint is forcing our whole leg to inherit rotations off the IK target. If we select this thigh bone again and look at our orientation constraint, the orientation constraint has a few properties, one of which is the ability to add multiple targets. If I click on the Add Orientation Target button again, this time I'm going to add the pelvis as an orientation target. Each target has a weight, so now when we rotate this IK target, our whole leg is inheriting rotations off both the pelvis and the IK target. We can also weight the amount of influence the pelvis and the IK target have on the IK system. We may want to dampen the pelvis's influence and bias the whole IK system to follow the rotation of the leg more closely. Now with the left leg, we're going to look at another way we can customize the IK system. The goal in this second example is to make the knee follow a third object in the scene. So if I select the character, put the character back into setup pose, and come to the modifier panel, we can see we have buttons, and one of them is the Add Bone button. If I press Add Bone, we can see that there is a new bone being added to our pelvis. We're going to pull this bone out in front of the character. We want our knee to follow the position of this bone in world space. Now if we move the pelvis, we can see that this bone follows the movement of the pelvis, and if we go to out of setup pose, move this bone down. Okay. Now if we select this leg and go to the limb animation rollout, we're going to put this leg into FK. The leg dangles down, and now it ignores both the IK target, and of course this bone has no influence over the position of the rotation of this leg. To change that, we select the thigh bone, once again come out to our available controllers, and for a rotation controller now we're going to assign the Look At constraint. The Look At constraint, we're going to add this bone as a target for the thigh's look at. Now, to correctly configure this Look At constraint, we need to add an upnode node. For an upnode node, we will use the IK target. Now, given that X is down on this thigh and Y is forwards, we'll use the Y-axis as our look at, and we're going to flip it so that Y is actually going forwards. Now our thigh bone is looking at our target bone, and it's also using the IK target as an up node. So now when we select this thigh bone again, come back to our limb animation rollout and put our leg back into IK, we can see that when we move this pelvis around, we are still in IK, but the position of this node is now controlling the rotation of the knee. So FK-driven IK gives users and artists the ability to customize the animation of the IK system very effectively, and using the powerful controller system in Max, we can modify the animation of this IK system, adding extra functionality to our basic overall structure.